In 2023, worldwide agricultural consumption of pesticides increased to about 4.3 million metric tons. They come in a wide variety of forms, with one objective: to eliminate pests that harm crop growth. But what if I told you that these pest eliminators cause more harm than the pests themselves? Watch as I take you into the world of the science behind integrated pest management and the vital role it plays in safeguarding our food systems. Integrated pest management is an approach to pest control that uses a combination of chemical, biological, and mechanical controls. The aim is to reduce crop damage to tolerable levels, rather than total pest elimination. Well-designed IPM programs can reduce costs and pesticide use by 50 to 90% and reduce fertilizer use. There are 5 steps to ensure that integrated pest management is working at its prime level. The first step is to identify and monitor. Carefully monitoring pest levels is the single most important starting point to ensure how much of the pest we are tugging at here. The second step is to evaluate by implementing controls when damage is unacceptable or the population is too high. The next step is to prevent. This can be done by encircling trees with climbing barriers, rotating crops to prevent the buildup of pests and diseases in the soils, and proper sanitation. And finally, the last is to act on it. Infestations can be contained using pheromones and biological controls. If these don't work, targeted use of narrow-spectrum pesticides can be used instead. It's important to remember that every method of pest control has costs. Conventional costs include the cost of the pesticide and the fuel to run the machinery to apply it. The IPM costs include the monitoring and labor costs. The higher cost of labor is offset by the lower cost of pesticide application. Fewer resources involved in IPM means more sustainability, which then means it is less likely to encourage pest resistance. Crop monitoring also helps monitor the level of pest damage. Cultivation controls combine crop management and physical means to reduce pest numbers. It is based on the reduction of pest species to a tolerable level using natural parasites, predators, or pathogens. Precautions that should be taken when implementing a biocontrol program include the quarantine of potential biocontrol agents while their risk to natural ecosystems is assessed. This involves investigating the control species' biology so that predictions can be made as to how it will survive. The question is, how can we implement biocontrol in a way that we can suppress these natural ecosystem pest populations without causing harm to crop damage?
Biocontrol is a method that utilizes live organisms to rein in pest populations, minimizing the damage they inflict on our ecosystems. Pests often encounter natural enemies such as predators, parasites, parasitoids, and pathogens, which play a crucial role in maintaining balance and preventing the spread of pests. Given the adverse effects of pesticides on both human health and biodiversity, biocontrol emerges as a compelling alternative. It offers 3 unique strategies, which are as follows. Firstly, there's classical biological control, where foreign natural enemies are introduced to combat invasive species, disrupting their destructive dominance. This method requires an extensive ecological understanding to ensure proper integration. Next is augmentative biological control, particularly in controlled environments like greenhouses and nurseries. Here, biological control agents are released to bolster natural enemies, a strategic maneuver to amplify their impact in areas lacking these defenders. Lastly, conservation biological control involves manipulating habitat, plant diversity, and production practices to expand and strengthen natural numbers. Yet, the path of biocontrol is not as simple as the straightforward act of pesticide spraying. Biocontrol demands a comprehension of pest and natural enemy ecology and behavior, meaning it will require a little bit more work, making it up to the user whether it is worth it for their individual situation. Consumers who are concerned about the repercussions of widespread pesticide use see biocontrol as a sophisticated, eco-friendly solution that empowers nature's defenders to keep our environment thriving.
In addition to biocontrol reining in pest populations, the crops themselves can also be manipulated to reduce the amount of pests, as seen with crop rotation and intercropping.
Crop rotation is a strategy to help with pest control. Crop rotation is basically rotating between different crops every growing season so pests can't get attached to the plants. This could be within 2 or 3 different plants, or it could be more complex and rotate between 12 to 15 different plants. Organic farmers rely on crop rotation because they don't use pesticides. It's a safer, more environmentally friendly alternative. Crop rotation is most effective against insect pests with a limited host range, long life cycle, and limited ability to move from one field to another. The goal of crop rotation is to interfere with the needs of pests through their life cycle, to interrupt their patterns and habits of feeding on the crops. It is important to be familiar with the insect's life cycles, feeding habits, and crop preferences of pests. Crop rotation will not control all insect pests, so it doesn't always prove to be the most productive.
And then there's intercropping. Intercropping is the practice of growing 2 or more crops in close proximity. You can put one plant in a strip nearby your cash crop or put both of them in the same bed, but the ultimate goal is to have enough biological interaction that it confuses insects and other pests with the amount of host plants, which results in lower pest populations and lower pest densities. A certain type of plant could even attract predators that kill the pests too. Studies have shown this to be a rather viable option. As compared to pesticides, it can save up to 29% more land use and 36% more fertilizer use. However, intercropping does have a big variability factor, which does deter some from using it. One crop can work one year and not the next, or if you're not careful, the plants can compete and whatnot. But if the farm system ends up, on the whole, overall doing better as a result of intercropping, it should be implemented.
Regardless if it's biocontrol, crop rotation, or intercropping, there are some cons to IPM on the whole that causes people to still to pesticides. In addition to the unpredictability that IPM can have, it's also known to take a lot more effort for IPM systems and farms to function effectively. Farmers have to constantly monitor pest levels to determine which IPM method to use and be ready to change those methods. This also adds labor costs. Plus, it could be inefficient in achieving the maximum yield of a farm. Ultimately, it is going to depend on each individual farmer's situation to determine if integrated pest management is the right route to go.